Today in pre-cal we learned about horizontal and slant asymptotes. To be able to calculate these or figure out which one applies in a particular situation, it'll be easiest if you'll memorize this little saying, which is Bobbio, Botno, eats DC. And it might seem a little bit silly at first, but I promise it will help you remember the three cases that might happen when you're trying to find your horizontal or slant asymptotes when referring to rational functions. Bobbio stands for big on bottom, y equals 0. Botno stands for big on top, no horizontal asymptotes, they're oblique. The word oblique means slant or sideways or different than horizontal. Each DC is exponents are the same. Divide coefficients. So each one helps you remember which case is happening and what you need to do. When I say big or small, big on top or big on bottom or exponents are the same, each time I'm looking at the highest exponent or the degree of the top and the highest exponent of the bottom. When I compare those two exponents, either the bigger is on the bottom or the top, or they're exactly the same. Let's look at some examples. Number 1, f of x equals 2x squared over x squared minus 1. Now, all the things that have applied so far when we've talked about rational functions still do, but today we're only focused on horizontal and slant asymptotes. Notice that the exponent here is 2 and the exponent here is also 2, so they are the same. This would be each DC. Since they're the same, I divide my coefficients. So 2 over 1, I don't even care about this because it's not the coefficient of x squared. 2 over 1 reduces to 2, so my horizontal asymptote is y equals 2. Let's try another one. Example number 2. f of x equals x squared plus x minus 2 over x squared minus x minus 6. Okay, the exponent up top is 2, the highest exponent on bottom is also 2, so again this is each DC. And my horizontal asymptote can be found, always a y equals line, by doing the ratio of the coefficients, 1 over 1, which is 1. That should pretty well cover how to do each DC, or when the exponents are the same. If it was something like 4 over 8, it would reduce to 1/2, and that's okay. Yes, you do need to reduce, and it's okay to have a fraction. Example number 3. f of x equals x squared minus 2x plus 1 over x cubed minus 9x. This one, the exponent on the bottom is 3, the exponent on the top is 2, so big on bottom. So this is Bobbio. And when it's big on bottom, the horizontal asymptote is automatically y equals 0. Nothing else to do, nowhere else to look, nothing to worry about there. If the bigger one's on bottom, the horizontal asymptote is y equals 0. Okay, let's look at another case. Example 4. f of x equals x squared minus x minus 6 over x minus 1. On this one, the exponent of the top is 2, the exponent on the bottom is 1. So this would be big on top, or botno. When I have botno, I have to divide. Now, last week or 2 weeks ago, we learned 2 different methods of division, long division and synthetic. I'm going to show you long division on this one so that we can review both types. The bigger number goes, or the top number goes on bottom. The smaller one, or the outside one, goes on the over here. How many times does x go into x squared? X times x is x squared. X times negative 1 is negative x. Remember, I flip both of my signs, cancel common factors, push my remainder, and when we're doing Bobbio Botno, this last remainder does not matter, so I'm just going to leave it alone. And my horizontal asymptote then is my answer here, which is y equals x. Okay? When you have Botno, you have to divide. Let's do one more that's Botno to make sure we've got this. Example number 5. f of x equals x minus 2 times x plus 3 times x minus 1 all over x plus 2 times x minus 1. Now, on this one, notice that it's already in factored form for you, which would be nice when you were doing those other pieces previously. In this case, it's not particularly difficult. All you need to think about is if I multiplied x times x times x, each of those, the top would be x cubed, and the bottom would be x times x, which would be x squared. So big would be on top again, so this is again Botno. You will probably notice that these provide a hole, so I can cancel those out. Somebody asked a great question in class today, which is, if I cancel those out first, will that mess me up? No, because then this would be x times x, which is x squared over x, which is still bottom. Now we need to divide. This time I'm going to remind you of how to do synthetic division. On the outside, remember, you flip your sign. On the inside, you need it not in factored form, but expanded. So let's go ahead and FOIL this. X times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. I can combine these middle terms. And it'd be x squared plus x minus 6. So I'm going to write 1, 1, and negative 6. If I pull the first one down, I have 1 times negative 2, which is negative 2. Negative 1 times negative 2 is 2, and that's negative 4. Remember, we never care about the remainder when it comes to finding these horizontal asymptotes. Also, I started with x squared, so this first one is going to start with an exponent 1 less, so this would be 1x minus 1, or y equals x minus 1. And that's my horizontal asymptote in this case. The homework for this is A14, and it is a half sheet. And you will be combining all the things we've learned previously this week with how to find the horizontal or slant asymptotes. Remember, Bobby O'Bot, no EHDC, commit that to memory, and that will really help.